Number 6. Okay, so now we have a 45, 45, 90 triangle. Given the 45 and the 90, meaning this other angle over here has to be 45 degrees. I am going to term this triangle as the original triangle, just like I did in the previous problem, and I'm going to use special right triangles to solve for x and y. So what I'm going to do is I'm going to create another triangle, just like the one that I'm given here. And the angles in this second triangle that I'm created are going to be the exact same measurements in the exact same spots, 45, 90, and 45. I'm going to term this triangle the new triangle, and this new triangle is going to have the pattern that a 45, 45, 90 special right triangle follows, which is 1 and 1 and the square root of 2 on the hypotenuse. Okay, and what I'm going to do is I'm going to create, just like I did with the previous problem, I'm going to create two fractions. My fractions are always going to be the original triangle's values on the numerator, the new triangle's values on the denominator. So let's go ahead and start with x. So x in the original triangle corresponds with 1 in the new triangle. So one of my two fractions that I'm going to create to help me solve for x is going to be x over 1. And then I'm going to go to 18, and 18 in the original triangle corresponds with the square root of 2 in the new triangle. So my second fraction is going to be 18 over the square root of 2. I cross multiply, and then I'm going to use algebra to solve for x. So x multiplied with the square root 2 is x square root 2. And then 18 multiplied with 1 is 18. Those two results are equal to each other, and now I would divide with the square root of 2 on both sides, and the square root of 2's will cancel out, and I would get x is equal to, and then I would let my calculator do the work to figure out what 18 divided by the square root of 2 is. Pulling up the internet, hopefully rather quickly and not super slowly. I'm going to go to Math Tools on Desmos.com, drop down menu, click on Scientific Calculator. 18 divided by the square root of 2, 12.7. We're going to go ahead and round that off. So x is equal to 12.7. Same idea for y. So to solve for y, I'm going to create two fractions. I'm going to start with the original triangle with the y. You can see y corresponds with 1. So I get the fraction y over 1. And then for my second fraction, I'm just going to use the same second fraction that I did in my x, which is 18 over the square root of 2. And you can see this is the exact same problem as x. The only difference is I have y. So y is going to have the same answer as x. So x and y are both equal to 12.7. Whenever you have a 45, 45, 90, because the pattern is 1 and 1, that tells you those two legs are always going to be the same, x and y. All right? Number 7, find the angle measures below using inverse trig. Functions round to the nearest tenth. So I'm going to go ahead and solve for a first in this problem here. So a is going to be my reference angle, and since I'm working from a, that means that the side where the 12 is on, that is going to be my opposite side, and the side where the 18 is on, that is going to be my hypotenuse side. This means to solve for a, I'm going to use sine, okay? The definition for sine is sine of the theta angle is equal to the opposite side over the hypotenuse side. Using my diagram, theta is a. The opposite side is 12, and the hypotenuse is 18. So my equation is sine a is equal to 12 over 18. Now, I want to know what a equals. So I need to eliminate sine from my equation. And the way that I do that is I am going to multiply both sides of the equation with the inverse sine function, which we represent as sine with the exponent of -1. When you multiply the inverse sine function with sine, they cancel each other out. So I get A is equal to the inverse sine, and then the fraction 12 over 18. Okay, and then to figure out what A is, I let my calculator do the work for me. So I go to my calculator here, and I'm going to activate the inverse sine function. There it is. And then I type in the fraction 12 over 18. And whatever the calculator says, that's the answer. So my answer is 41.8 degrees. So in this problem, A is equal to 41.8 degrees. Okay, now to find B, once we know what A is, to find B is very easy. And the reason is because I know the three angles in a triangle are 180 degrees. So what that tells me is that B plus the given 90 degrees plus the A angle, which is 41.8 degrees, those three angles have to add up together to equal 180 degrees. Okay, and then I use this equation. So I would subtract 131.8 from each side of the equation. I combine the 90 and the 41.8 to make 131.8. And that would give me B is equal to 100 minus 131.8, which would be 48.2. So there's your answer for B. A is 41.8, B is 48.2. Okay. All right, moving on to number 8 here. Find the angle measure below using inverse trig functions. We're going to round to the nearest tenth. I'm going to solve for C first. So C is where I'm going to be referencing from. That makes the side where the 18 as the opposite side, and that makes the side where the 10 is on the adjacent side. Opposite and adjacent mean that I'm going to use tangent in order to solve for C. So by definition, the definition of tangent is tangent of the theta angle is equal to the opposite side over the adjacent side. From my diagram, theta is C angle, equals the opposite side is 18, and the adjacent side is 10. So my equation is tan C is equal to 18 over 10, and C is going to be my answer in degrees. So in order to solve for C in this problem, I need to eliminate tangent. And the way that I do that is I multiply both sides of the equation with the inverse tan, which we represent as tan with a -1 exponent. Inverse tan cancels out tan when multiplied together, and we would get C is equal to the inverse tangent of the fraction 18 over 10, and then to find out the exact value for C rounded to the 10th, I'll let my calculator do the work. Activate inverse tangent function on your calculator. Type in the fraction 18 over 10, 18 over 10, and my answer is 60.94, and that is closer to 60.9 than it is to 61. So 60.9 is how I'm going to represent the answer for C. 60.9 degrees. Now, to find D is much more simpler. I actually don't have to use the trig functions. I can if I want to, but I don't have to. I know that the three angles in a triangle add up to 180 degrees. So that means the D angle plus the given 90-degree angle plus the C angle, which I just found to be 60.9 degrees. Those three angles have to add together to equal 180 degrees. And I solve this equation for D. I would subtract 150.9 from both sides of the equation. I combine the 90 and the 60.9. That's where I got the 150.9 from. And then, whoops, D would be equal to 180 minus 150.9, which is 29.1. Okay, so D is equal to 29.1 degrees. All right, moving on. Number 9. Simplify the following expressions, and I want you to show your work. Okay, so I have 27 to the 4/3 power, or 27 with an exponent of 4/3. So what we need to do is, when you're doing these problems and you're showing your work, you want to focus in on whatever number is in the denominator of the exponent. In A, it is 27. So what you do is you go to the 27, the base, and you say to yourself, can I rewrite 27 as some number smaller than 27 to the 3rd power? And the answer is yes. 27 is just 3 to the 3rd power. So I rewrite my expression as 3 to the 3rd power, which is 27, to the 4/3 power. Okay? And then I simplify this expression out. So to simplify this out, I would take the 3, which is the base, and then I would multiply the exponent 3 with the exponent 4/3. Those 3's would cancel out. So this becomes 3 to the 4th power, and 3 to the 4th power is equal to 81. So A simplifies to 81, and that's how you would show your work. Moving on to B, notice in my exponent, the denominator is a 3. So what I do is I go to 1,000, and I have to rewrite 1,000 as some smaller number than 1,000, which in this case would be 10, to the 3rd power. 10 to the 3rd power is equal to 1,000. So I rewrite my expression as 10 to the 3rd power, then to the 2/3 power. Okay, and then I simplify this. The way that I simplify it is I would keep the base of 10, and then I would multiply 3 with the 2/3 exponents, where I'm using the power to a power rule, which says when you have one power, then in parentheses another power, you multiply those 2 powers together to simplify. Okay, 3 times 2/3, because those 3's would cancel out, just makes it 10 to the 2nd power, and that is equal to 100. So B is equal to 100. C, I have 64 as my base. I have an exponent of 4/3. The denominator is 3. So I want to rewrite 64 as some number smaller than 64 to the 3rd power. That still means 64, and that would be 4. So I rewrite 64 as 4 to the 3rd power, and then I have this exponent of 4/3, and then I simplify. I keep the base of 4. I multiply the 2 powers together, the 3 with the 4/3. Those 3's would cancel out. This becomes 4 to the 4th power, and then you figure out what 4 to the 4th power is equal to, which is 256. So C works out to 256. Okay. Now, when I get to D, I cannot do D. I cannot show any work for D, and the reason is there is no number to the 2nd power that is equal to 125. So the only way you could have done D is you actually had to use your calculator. So what you do is you type in the base 125. Notice it's 125 as the base. Then you type in the exponent of the fraction 3/2. Okay, and I'm going to click on that. And then I need to make the exponent 3/2. So I'm going to activate parentheses so it stays in parentheses 3/2. And you can see the answer is, it's a really long decimal. And so I'm just going to say 1,397.5. Okay, kind of a weird one, 1,397.5 for D. Nothing more you can really do there to figure that one out. Okay, last one, letter E. I have the base of 16. I have an exponent of 4. You're going to have to rewrite 16 as a smaller number, which in this case is going to be 2 to the 4th power. 2 to the 4th power is 16. So then I have I put that in parentheses, and then outside I have another exponent, the 3/4 exponent. And I simplify this. And the way I simplify it is I multiply the 4 with the 3/4. The 4's cancel out. This becomes 2 to the 3rd power, and 2 to the 3rd power is equal to 8, because remember 2 to the 3rd power means 2 times 2 times 2. Number 10, a study was conducted to see if there is a relationship between height and IQ. Use the two-way table to answer the following questions. Okay, so A, I want to find the probability that a person in this study is tall. So you go to the total, which is 130. And then that's going to be the numerator of your probability answer. And then the denominator is going to be the total, which is 185. Oh, sorry, my parrot's talking right now. All right, B. Now I need to find the probability of a person in this study would be above average IQ. So I go to my table. Above average IQ is this column here, and you can see the total of the column is 105. So that's going to be my numerator of my probability answer, and then the denominator is the total, which is 185. So B is the fraction 105 over 85, and I don't care if you reduce that fraction or not. And I'm not going to reduce it for time's sake. Okay, C, now I'm going to find the probability of that somebody from this survey or this study is above average IQ, and they're also tall. So since this probability involves the word and, I have to go to my table and find the exact spot where above average IQ, which is this first column, comes together with tall, which is that second row. And you can see above average IQ and tall come together right at the number 80. So that's your numerator for your probability answer. And then the denominator is the total, which is 185. So 80 over 185 for C. Okay, D. Find the probability of a person having above average IQ given they are tall. Okay, now this one involves the word given. So what this tells us is this is what we call a conditional probability. I just put a condition on the probability question, and the condition is whatever is after the word given, which is they are tall. So the way you answer this is you go to whatever is after the word given, they are tall, find that total, which is 130. That's going to be the denominator of your answer. Now the numerator is going to be how many people out of those 130 people, and I can only choose from the people who are tall, the ones I just circled. How many of those people have an above average IQ? And you can see that it is 80 of them. So my answer is 80 out of 130. And once again, you could reduce that, but I really don't care if you reduce or not, and I'm not going to. All right, part E. Based on your answers for B and D, complete the statement below. A person who is tall is more, less, equally likely to have above average IQ. So what you do is you go, here's how you answer this. You go to your answer for B, which is 105 out of 185. You go to answer to D, which is 80 out of 130. Because both of these answers are more than 50%. Okay, and I know that because 105 is more than a half of 185, and 80 is more than 130. That means that a person who is tall is more likely to have above average IQ. Okay, and the reason why it's more likely is because though the answers, the probabilities for B and D were over 50%. If they were less than 50%, the answer would be less likely. If they were exactly 50%, both of them, it'd be equally likely. Okay, and it says give evidence for your reasoning. I just did more than 50%. Okay, all right. Number 11, 12, 13, 14 is questioning our knowledge on four-sided shapes. Name all shapes that have the given properties. A quadrilateral with opposite sides parallel. Okay, so you want to name all the quadrilaterals where the opposite sides are parallel. That would be a parallelogram, a rectangle, a rhombus, and a square. Number 12. Name all shapes that have the given properties. A parallelogram with congruent diagonals. So notice this shape is saying it has to be a parallelogram. So you can only choose from the shapes that are parallelograms. And from those shapes, which of those shapes have congruent diagonals? There's two of them, a rectangle and a square. Okay, so that would be 12. Number 13, name all shapes that have the given properties. A parallelogram with four right angles. Now once again, notice, said a parallelogram, so we can only choose from the shapes that are under the parallelogram part of the parallelogram family tree. And from those, we have to choose the ones that have right angles. There's two of them, and it's the same answer as number 12. A rectangle has four right angles, and a square has four right angles. And then the last one, we're going to name all shapes that have the given properties. A quadrilateral, so this means it could be any of the four-sided shapes where with diagonals that intersect at right angles. There's three of them. A rhombus, a square, and the third one is a kite. Okay. Number 15. We're going to complete the two-column proof below. We have our reason bank of what we could choose for our answers. Okay, notice in my proof, remember we've talked about all proofs have commonalities with them. There is always a given. We're going to prove that, or our given is ABC, shape ABCD is a square. And then we're going to prove that A to F is congruent to C to F. Okay, so statement number 1 is your given. Okay, so the first reason is given. Okay, the statement number 2 says that side A to B is parallel with side D to C. So I'm going to go ahead and mark that with the arrows. And then I'm going to choose the reason. How do I know that A to B is parallel with D to C? Well, obviously it's not given. So I have to go down to my reason bank and I have to pick which one of these answers, and it would be this one right here. Square has opposite sides parallel. Okay, so my answer would be square has opposite sides parallel. All right. The next statement, angle B A F is congruent with angle DCF, so let's mark those. Angle BAF would be that angle right there, which I just put that congruent mark in, is congruent with angle DCF, which would be that angle right there. So why are those two angles equal? Well, or congruent. Okay, I've got my parallel lines. I've got a transversal, A to C, and like we talked about in class, actually today, whenever you have parallel lines and whenever you have a transversal, that means you have alternate interior angles. So my reason would be right here. Parallel lines, alternate interior angles are congruent. You could just write AIA, alternate interior angles, which is that reason right there. Okay, next one. A to B is congruent with C to D. So we are saying that side A to B, this top side, is congruent with side C to D. Okay, obviously that's not given, but remember we were given it was a square, and remember in a square, all the sides are congruent. So my reason would be I'm using the definition of a square. Okay, by definition, a square has 4 congruent sides, which means that that top side, A to B, has to be congruent with my bottom side, C to D. My next statement, angle AFB, that angle right there, right at F, I'm going to mark that with the congruent mark, is congruent to angle CFD. There's CFD with that angle right there. What type of angles are those? Well, remember, when X marks the spot, we always have vertical angles. So my reason would be vertical angles here. You do not have to write out the whole thing. Vertical angles are congruent, which is in the reason bank. Okay. And then my next statement, I have to actually complete it. So triangle CFD, so I'm going to highlight that one. CFD, whoopsie, sorry about that. That triangle there that I just highlighted is congruent to what other triangle? Well, it would have to be congruent with this triangle right above it there. And I would have to name it AFB. So triangle CFD is congruent to triangle AFB. And what would be my reason? I have an angle, and a side. So angle, side. And my last statement is what I'm proving. AF is congruent with CF, and that would be the CPCTC rule. CPCTC. Number 16, completing the proof. A to C is congruent with A to B. That's my first given. Notice, that's my first given. So that's what I put in my first statement. A to C is congruent with A to B. Now, the reason bank that was for number 15 does not apply to number 16. Okay, and there's no reason bank for number 16. So I actually have to come up with these myself. Okay, the second one is a typo. Notice the second given is A to D bisects angle CAB. And the second statement is AC bisects angle CAB. That C there is supposed to be a D. And my reason is that was given. So remember, when you're filling out a proof, the first couple lines are always your givens. Okay, now, this second statement, A to D, that means that line right there, AD, bisects angle CAB. Angle CAB is that big angle up at the top. When you bisect something, you cut whatever's being bisected, angle CAB, into 2 smaller equal angles. So this tells me that this angle here is congruent to that angle there. So that's going to be my third statement. I'm going to have to name those 2 angles. Angle CAD is congruent with angle, and I'm going to name the other angle up here, and I would name it angle BAD. So that would be my third statement. Okay. Statement 4, the reason is reflexive property. And remember, the reflexive property is used when there is a line segment, and that is AD, that is equal to itself in both of the triangles. So AD is congruent to AD in both of the triangles. That's called the reflexive property. It's kind of like a reflection in the mirror idea. And now you can see I have 2 sides that are equal in each triangle. I have 1 angle that's equal in each triangle. I could now say that triangle ACD is congruent with triangle ABD. And that would be by the side angle side rule. And then the last statement is what I'm proving. Angle 1 is congruent to angle 2. And that would be the idea of the CPCTC. There's the rest of Unit 7 review.